Hi guys, you welcome back to my channel. Base chemistry call, a quick one. Looking at what we have on the board, we have chemistry Neco 2024 examination. I also want to appreciate the effort of all of our subscribers as today for taking us to 900 plus. So back to the Neco 2024 solution to the just concluded examination. And I told you guys that I'll be picking only the organic chemistry first before I move to either the physical chemistry as well as the inorganic chemistry. But then, in external examination, they always put both organic, physical, and inorganic chemistry under some corrections, while others will only be what strictly the organic chemistry. Is that clear now? So now back to the class. The first question goes thus: using chemical equation only, we are asked to distinguish between ethene and ethyl, and for us to do that, we need to write out the chemical formula of each of the ethyl and ethene. So back to the board. Now we have this. Ethene is C2H4, ethyl is C2H2. But how do we differentiate this, or how do we distinguish this chemically? It is very simple. Note one thing. Here we have what? A double bond. Here also we also have what? A triple bond. But how do we differentiate the number of carbon atoms that bond with the double bond as well as the triple bond? Is that clear now? So this is it. Let's show the structural formula of both. So for this we have this. So you can see one hydrogen is here, another one is here, another one is here. So for this we have triple bond. Now, what is the difference between ethene and ethyl? The first thing that you can easily use to distinguish between both ethene and ethyl is that for every ethene they have double bond, which are being classified as the alkane. And if you are an undergraduate out there which you are preparing for 2025 WAEC, Neco or JAMB examination, this particular video is for you. Is that clear now? And for every ethyl they have triple bond, which will be 1, 2, 3. And note one thing, I dropped a video earlier on how you can easily identify the pi bond and the sigma bond. Is that clear? We have the pi bond to pi bond, we have the what? The sigma bond to what? The sigma bond. So that is, we have a lone pair bond pair, or bond pair lone pair, or lone pair lone pair, or bond pair bond pair. So for this now, we're having two carbon atoms attached to a double bond. That is the difference. But yeah, we have, if we look at it now, there's two carbon atoms here attached to what? A triple bond, but the number of hydrogen atoms that surround this is 2. While the number of hydrogen atoms that surround these carbon atoms is what? 4. So if you have to distinguish it, this is how you're going to just put it like ethene has a double bond with two carbon atoms attached to the what? The double bond, while ethyl has a triple bond with two carbon atom attached to it. You can see for the first one I made mention of what? Double bond. The second one I made mention of what? Triple bond. Is that clear now? So now back to this. Name the compound formed when ethene polymerizes. The compound is polyacetylene. But note one thing, there's what we need to know in organic chemistry when we talk about what? Polymer. Listen attentively, okay? Let's say polymer are large molecules which are separated by the combination of a large number of small molecules or monomers. So I will underline this. So guys, so for every polymer, we take a look at how large molecules are combined or separated by the combination of a large number of small molecules to give us small molecules or monomers. The main reason why I'm making emphasis on this is because when we get to this point, we are asked to we should write the structure of the compound in AI. Don't forget that chemistry core, we are not only treating the past question and giving the answer only. Rather, we are going to explain how we have that answer. So pay max attention. So for this now, we have to write the structure of the compound in this. Note one thing, for every polymers, we are talking about ethyl. So now, let's take a look at it now. Ethyl is subjected to semi-hydrogenation. So if this is subjected to semi-hydrogenation, it will yield what we call ethylene, which we all know as what? Ethyl. Sorry, which we all know as what? Ethene. So for every ethyl polymerizes, when it polymerizes, are you with me now? There's what we call ethene is being subjected to what we call semi-hydrogenation. And when it's being subjected to what? Semi-hydrogenation, we are going to have this. See, double bond, a carbon hydrogen is here, another one is here. So it is going to form a polymer. And note that for every polymer, we have two types: the natural polymer as well as the synthetic polymer. Those natural polymers, we have it naturally from protein, are you with me now? Fat and oil. But the synthetic polymer, it is common in our environment, the polythene or nylon. So for this, we are having one hydrogen atom here, carbon is here, hydrogen is here. So this, there is a what? A small letter N here. So when we talk about this small letter N, there's what we call a giant molecules in chemistry. I'll be dropping video on that as well, but we are not going to that now. So if ethane polymerizes, for ethane to polymerize, they are being subjected to semi-hydrogenation to yield ethylene. And that ethylene is also the same thing as what? Ethene. Is that clear now? So with that, this particular structure here shows how we are having our ethylene to give us a polymer. Because if it does not polymerize, we cannot have what we call a polyacetylene. Why needs to give us a what? A polyethylene. Please take note of this. What we have here is something as what? Polyethylene. So guys, when you come to organic chemistry, there's one thing you need to know about organic chemistry. The secret behind it is that it is not all about naming. The main objective and the main goal of organic chemistry is the mechanism. Apart from the mechanism, how to easily differentiate the physical properties of a particular compound under the alkane group, either alkane, alkene, alkyne, how to differentiate them under their respective mechanism, either the physical or the chemical properties. Is that clear now? So guys, this is how ethyl polymerize. Ethyl is subjected to semi-hydrogenation, which we produce ethylene, which is this, and this is our ethylene. Coming to this place, there is giving us a what? A product of polyethylene. And that polyethylene, the family of polymers, you can easily have what? A polyacetylene. So I said name the compound form when ethyl polymerizes. Is that you put it as polyethylene, or we have it to be what? Polyacetylene. Is that clear now? So guys, the next question is 6bi. What will be observed when Ferrin solution is added to reducing sugar? So for Ferrin to be added to reducing sugar, it will give us a particular color, and for us to have that color, it means that Ferrin to be added to reducing sugar must have undergoes a process where we call a complex formation, and that complex formation can be that of the aldehyde, which we all know as alkana, or we have ketone, which we all know as what? Alkanone. And with that, if those two undergoes a complex formation, when Ferrin solution is added to reducing sugar, it will change that reducing sugar color to red. Is that clear now? That's the secret. So the second one is Melin reagent is added to protein. When Melin reagent is added to protein, there is a complex formation of an atom that is formed there, and that complex formation of an atom is called the amino group. And when an amino group is just like you pick your egg, mostly in the lab, when you pick your egg and you mix it together, or when Melin solution is added to egg, egg is an example of what? A protein. We are going to have a blue. Is that okay now? A blue color is what? Observed. So the last one is sodium metal is dropped into a beaker containing ethanol. We all know how the kind of taste ethanol gives, how burning it is. But here, if a sodium metal is added into a beaker containing ethanol, they will form a rigorous reaction will occur, producing water and sodium ethoxide. Again, when sodium metal is dropped into a beaker containing ethanol, a rigorous reaction is observed or occur, which will yield or produce water or hydrogen gas and sodium ethoxide. Is that clear now? So guys, the next one is, this is not a question under the organic chemistry as I've said earlier, but due to the fact that this question is under the number 6 question and I must do justice to it, so that's more reason why I'm using the opportunity or that avenue for those of you that have issues with some part of solubility. So with this now, the calculator please. So with this now, calculate the solubility in mole per dm cube of 4.9 gram potassium trioxychloride 5 in 200 cm cube of water at 66 degrees Celsius. The first thing we are going to take a look at is the molar mass of potassium trioxychloride 5 of potassium trioxychloride 5. So we have 39 plus 35.5 plus 16 times 3. So with that we have 39 plus 35.5 plus 48. So now we have 39 plus 35.5 plus 48. So we have 122.5 gram per mole. So the next thing we want to take a look at is the volume. Volume in cm cube. So we have 20 cm cube, and not wanting that 1 dm cube is equal to 1000 cm cube. So I'm going to divide this with this. So we'll be having 2 cm cube divided by 1000 cm cube. So let's see what we're going to have there. So you have this divided by 1000. So we have 0.02. So now the next thing is we are going to convert this to mole. However, for us to convert this to mole, it is very simple. We said converting potassium trioxochlorate 5. So what do you have here initially? We have 4.9 gram divided by 122.5 gram per mole. So it means that we have to convert this potassium trioxochlorate 5 in mole. So is that now, like I said, 4.9 divided by 122.5, we have 0.04 mole. So the next thing is solubility in mole per dm cube. So we have the mole of KClO3 potassium and what? Volume of solution. So what is our volume of solution? This we have, for this it is what? 0.04 mole divided by 0.02 dm cube. So 0.04 divided by 0.02. So we have 2 mole per dm cube. You can see, as simple as ABC. So the next thing now is we have to state the three physical properties of ethanol. The first one, they have a burning taste. So why did I say they have a burning taste? For those that are exposed to ethanol out there, the moment they sip it, they'll feel it in their what? Their body. So that's the more reason why they said they have a what? A burning taste. Because if you take alcohol of some percentage, you feel it in your what? In your body. The toxicity is what? Is very high. Is that clear now? So that when you take it, it will burn you and feel something is what? Is here already. So the second one is what? They are liquid at room temperature. They are colorless. But when you're in the laboratory, ethanol is colorless. Please don't mix ethanol and alcohol together. They are different entirely. There are some alcohol that have what? Color. So alcohol is different from what? Ethanol. Ethanol are the parents, they are the what? Let us say, let me make use of this one, the children of alcohol. So ethanol is what? Colorless at room temperature. Or we say they are what? A clear solution. They are clear and pure as our what? Water. H2O. Is that clear now? So the last one is write the equation for the preparation of ethanol from ethene. Now is when I talk about the mechanism of what? Under organic chemistry. But now we'll take a look at the mechanism of what? Alkene. And we are not using alkene alone, we are using the first member of alkene, which is what? Ethene. So the first one, I will say I have hydration reaction. So we have C2H4 plus water. So with this now we have double bond. So this kind of this thing here, we can say I made it something like we have bond pair here. Bond pair here is what? A lone pair here. Is that clear now? So if our water is coming into this, mind you can have what? OH negative and what? Hydrogen what? Positive. And for us to break this bond now, mind you, this can easily attach itself to this and this also can attach itself to this. By doing that, this will change to C2. Let's count now. 1, 2, 3, 4 initially. With the addition of the hydrogen ion, we have what? H5 plus OH. This is what? Ethanol. So that is why we call it what? Hydration. Is that clear? So the next one is sulfonation. Sulfonation reaction. C2H4 plus H2SO4. The same thing is this. Here I can separate it into two. One of this is coming to this place. We have what? C2H5. Here we are left with what? One hydrogen and what? SO4. The last one is hydrolysis reaction. So as an undergraduate, you need this particular video when it comes to preparation of what? Ethanol. Is that clear now? So what do we have here as a product here? You can take it to be your step 1, step 2, and step 3. So what do we have? C2H5 HSO4 plus H2O. So now this is where we are coming. Mind you, when you separate this into two, we have hydrogen positive, and here we have what? OH negative. So this one here will be reacting with what? There's a cleavage here. HSO4 plus H. Initially we have what? HSO4, but because of this hydrogen ion that is coming to this one, we have what? 2 H2SO4 back. So while this OH here will attach itself to this C2H5, so we have C2H5OH. So guys, this is the beauty behind chemistry. For you that have been our subscribers and you haven't any of your colleagues or friends who have a phobia for chemistry, this is the beauty behind chemistry that majority of you out there are finding difficult to understand. Do subscribe to my channel and don't forget to like, share in the comment box. Even if it is just thanks, do it to drop it there. We appreciate. See our next class. Thanks.